Hi, everybody. Thanks a million for making it out. We really appreciate you coming to the talk. Our talk today is From Model to Trust, Building Upon Tamper-proof ML Metadata Records. My name is Eoin Wickens. I work for HiddenLayer. I've been looking to secure the AI supply chain for about the last 3 years. And with me is Mihai, the infamous Mihai. Do you want to introduce yourself?
Hello. Probably I already introduced myself. I'm Mihai Maruseac from Ghost. You can find my profiles on mihai.page, Google Open Source Security Team. That's Ghost. Sorry.
Magic. So 2 years ago, and maybe a little bit more than that, our future started becoming our reality. We began to see AI really capture the zeitgeist of the moment, and models began to be proliferated, shared amongst people, and used widely in so many applications in our tech stack. But there was one big problem. There's no way to verify the trust or integrity of machine learning models at that time. And we found that traditional approaches to signing wouldn't work. Mihai was talking about Kaggle and the models that are hosted there, which are now starting to become signed. I want to point out as well that Hugging Face, 2 years ago at this point, had 160,000 model repositories. Today, they have close to 2 million in 2 years, kind of highlighting the scale of this problem. And this fantastic XKCD comic, which Mihai takes full credit for, we can see that so much of our tech stack today is basically relying on AI models with no verification, no signatures, and no provenance to understand where they came from, or if they've been tampered with, or if they're malicious. So what is different with models, and why can't we use existing signing principles to sign these artifacts? Well, models aren't just a single file. They actually comprise a number of different files across various different file formats to basically be used in one feed-forward pass of a model. The format disparity means it's very difficult to embed a signature inside every single one of these differing file formats, which means we need a way of signing arbitrary collections of files together. Also, fine-tuning is an interesting property of signing, or of models even, in which you will have to update files or weight files inside a repository to fine-tune it for your usage. Ultimately, you might not even need all the files in a model repository. And often you'll see different file formats or different versions of a model hosted, where you might see PyTorch versions of the model, Safe Tensors versions of the model, and one singular unified signature. Any small change to any one of these pieces will break it entirely. So we had to come up with a different paradigm. So about 2 years ago, we sat down to answer a few questions. And the main ones here are, who trained the model you're using? Has it been fine-tuned since? And do you have a record of this change? Has it been tampered with? Is the integrity assured of the model that you've gotten? And ultimately, can you prove it? So over the last 2 years, we've set up a fantastic group of people under the model signing project under the OpenSSF. This is part of the AI/ML working group. And I think at the beginning of April, we released v1.0 of our model signing library and CLI. And this allows us to sign collections of arbitrary files. We want to sign models, so that's what we're going to do. But this actually can be used for various different approaches. We wanted to make something as well that was PKI-agnostic, meaning that it didn't matter what type of infrastructure you were using to sign your models or to sign your software artifacts. We wanted to ensure that this was adaptable for various situations. And ultimately, we wanted to set out to prove integrity and trust in the AI supply chain. So you can check out our latest blog on this, actually, which dropped last night. It's been shared on the OpenSSF socials today, where we've branded and, I guess, formalized the specification of this signing format as the OpenSSF Model Signing Format, or OMS for short. And there's a lot more information in that blog, which we can touch on later. So today, AI is an intrinsic part of our tech stack. You no doubt see it's mentioned at pretty much every major conference from every major vendor. And signing and verification is finally here. This thing that we were missing 2 years ago that hadn't even begun to become formed has arrived. Now, signing acts as a fundamental building block towards so many different things that we can do to secure the supply chain. We have provable provenance, we have provable traceability, and it means that for compliance and security teams, we can leverage these signatures to ensure that there is trust, ensure that you are compliant, to ensure that you're secure. But now we need to look to you to help drive adoption of this standard, because without you, we won't have as much of a secure AI supply chain. So with that, I'll pass it back to Mihai, and he can take you on.
Thank you very much. So we have the library that we released in April, and you can go to the QR code to get to the GitHub repository for the library. We have the graphs of the star history and some statistics at the bottom. The library is both a library that can be incorporated into other Python frameworks. Like, our plan is to actually integrate this into ML frameworks. So for example, when you write a model in PyTorch, when you do model.save, behind the scenes, this also would at least hash the model, if not fully sign it. And you can download the library on PyPI. You can use it as the library, or you can use it as the CLI directly to sign models locally, verify model signatures if you don't trust where the model came from. It's very cool. You can use it from Docker. You can use it with the Python stack. Really nice. And now I'm going to go a little bit into the format of the signature itself. So the signature is a 6-store bundle. We have to have the signature detached from the model because there are so many model formats, and we cannot incorporate the signature inside each one of these models, because then it will be like a complete race against any new model that gets developed. Then we need to incorporate the signature into that, and then the next one, and then the next one. So we decided to detach the signature and just make sure that the model hubs know how to look for the signature and display the verified badge accordingly. So being a 6-store bundle, this is a DC envelope with the verification material at the end. And inside the DC envelope, we have the payload that actually contains the model. So let's look at the payload itself. The payload is an in-toto statement. So the type is like in-toto statement v1 with the predicate type model signing signature v1. That's the one that we are formalizing today. And we have under subject, we have the name of the model, which is informative, similar for SLSA, where the name of the subject is informative. And we have a digest, a hash that you can refer to the model in other metadata, in other supply chain documents. You can refer by the same hash. And then under the predicate field itself, we have every resource in the model, so every file with their path and their corresponding hash. And we also have the serialization method that has been used to compute the model signature, to hash the model. And I'm saying that these are put into the predicate itself because we actually have 2 ways to serialize models right now to generate the signatures. For models of small size to LLMs of relatively big size, we can hash every file into the model one by one and record their hashes individually. But once the models become very, very, very large and the files themselves become large, you can actually switch to hashing shards of the files. So the serialization method would be by shards. You can specify the shard size, and then if you look under name, it's the name of the file, and then the start offset and end offset for each individual hash. So that's why you call these resources instead of files. We actually want to support multiple ways of hashing the model, trying to pick the one that is most efficient on the architecture that generates the model, that trains the model. And with that, we can also go into extensions of this framework. So we want to be able to support hashing on GPU. So the method would be GPU hash, and you can specify more parameters into there. And we also want to be able to sign model cards or other ML metadata and put that into the signature itself. So now all the ML metadata would be tamper-proof. Basically, our idea is that all claims about ML models should be tamper-proof, tied to an identity, and all the verification and generation parts should be used in tools that ML developers are using. And with that, I'm switching back to Eoin.
Magic, thanks, Mihai. So yeah, look, we would love more participation in the project and our community. We've got some fantastic contributors that have really been mainstays for us. And we are actively planning out our roadmap to see what is next for this standard. We're looking at things like dataset provenance. We're looking at things like model metacard data. We really want to expand this to, as Mihai is saying, cover all aspects of the AI supply chain. Our next meeting, well, it's worth calling out that, and Mihai already spoke about it earlier in his talk. This is currently being worked on in 2 different groups. We have the model signing project under the AI/ML working group, But also the Coalition for Secure AI is working on guidance around model signing, around adoption, and how it can be used. That is equally as important. So if you wish to get involved in either of those, we'd absolutely love to have you there. For the next meeting, where we will hopefully discuss our roadmap and our plans and really seek community involvement in the next stages of this project, now that we've formalized the standard, our next meeting will be at 1 p.m. Eastern, July 7th, at the AI/ML Working Group under the OpenSSF. So yeah, let's ensure today's intelligent creations don't become tomorrow's security nightmares. And thank you. And I just want to give a massive shout out to everybody who's helped get this specification standard to where it is today. Daniel, who's here in the crowd in front of us especially, Martin, Laurent, Rich, and so many others across so many organizations that we are incredibly thankful for, and this really couldn't have happened without. So thank you so much.
We have a few minutes for questions. Yeah.
Pardon my ignorance if I didn't catch the earlier part, but ultimately, what are you signing? Model is a big thing, right? It's the data, it's the algorithm, it's the model card, and all these things. What exactly is being signed?
So right now, we are signing the files into the model itself, so the weights and the model architecture. So let me go to, I think this is the diagram. So right now, we are doing this signing here under train model, which only contains the model weights and the model architecture. The format itself for the signature would allow us to also generalize this, to also sign datasets, to also sign other metadata formats like the model evaluation, the model cards, and so on. And then we can incorporate everything into one single file or into multiple files and link them by the same hash.
If you're signing the architecture and the weights of the model, but if, let's say, it gets fine-tuned later, the signature will change, or you'll need to re-sign it because the weights changed. But if the weights don't change, then nothing has changed? Like, you can change the data set, and maybe the weights don't change?
So if you change the data set, but you're not training the model or you're not fine-tuning the model, then the model itself as the entity is still the one trained on the previous data set. You don't need to change anything.
Got it.
One other thing on that, we're also looking at chaining claims together. So let's say you do fine-tune a model from a base model, you can stitch that secondary signature or your later signature onto the original one, so that you actually have a full chain of provenance of how that model was changed over time, and that allows that kind of traceability within your development pipeline.
Is there any kind of signing for inference, or it's just up till training?
I don't think so at this moment.
Okay.
Are you also planning to chain the hashes from the training data set to the trained model, and so the whole thing? Great.
That's part of our future work.
Hi there. So you mentioned incorporating the model card in the signature. I was curious if you thought about going the other way around, because I guess the thing that a lot of folks will do if they're not aware of SigStore is just go look at the model card and be like, yep, that's the model for me, right?
Mm-hmm. Yeah, I think the point of interplay with existing things like AI-BOM and ML-BOM is really interesting as well in that aspect. I think it's a hard one because you don't want to reinvent the wheel, right? There's already so much work gone into defining all these different properties. However, sometimes having like a limited subset of that data required for that signature may work. Do you have any thoughts on that, Mihai?
Yeah, so there are tools that generate the model card for you, but right now that's just a text file or some collection of files that can be tampered with. So what we want to do is actually go into those tools, incorporate signing, and now when you generate the model card, you'll generate one that is tamper-proof. And then it can be its own separate file. It can be into the signature. That will no longer matter. It's just a way to display the information to users and also make it untamperable.
Can you talk a little bit more about what the difference is between the model signing project in OpenSSF and the effort in COSI?
Yeah, great question. So in the OpenSSF group, we're pretty much defining the specification and the tooling. The Coalition for Secure AI work is largely around, I guess, providing guidance around that utility. Also then, I think, and this is, I suppose, the effort into that is only starting out right now, but I think they have more long-term ambitions to really help influence the design of the project and feed that information in from like real-world usage and from trialing throughout the many constituent organizations. So I see them as working quite well in tandem and looking forward to seeing what comes out of it, really. Quick question.